Hello again, it's Mrs. Tremblay. It's time for yet another way to solve a quadratic equation. And today we're going to talk about how to solve a quadratic equation using square roots. So to start off, just a little review of square roots. We use this symbol to show the square root of a number. It's called the square root sign, or we call it radical sign, which I prefer because radical is just radical. So, square root of 9, it's 3 because 3 squared is 9. The square root of 1 and 96 hundredths is 1.4 because 1.4 squared is 1 and 96 hundredths. Every positive number has two square roots. Maybe you didn't realize this before. We haven't talked about it yet, but it's kind of like introduced as we go. So you've learned this part, but maybe haven't really focused on this yet. Well, now it's time. The square root of 9 can be considered a positive 3 or a negative 3, because isn't the quantity of negative 3 squared also 9? Yep. So that's going to be critical to us within this unit, especially when we get to the quadratic formula, which is coming soon, theaters near you. Alright, so if I ask you to take the square root of a number, this means take the positive square root of a. And if I put a negative sign out there, it means the negative square root of a. For example, the square root of 64, that's 8. And the opposite of the square root of 64, that's negative 8. Okie dokie. So far, so good. Okay, so I tell you which one I want, basically, by putting that negative sign out there. Negative numbers don't have square roots in our number system. In our number system, in the real number system, we are not going to talk about imaginary, but this is where it would come up. So you can see why. If you try to find the square root of negative 9, it's impossible. What number can you multiply by itself to get a negative 9? What do you think? Well, 3. Well, 3 squared, yeah, that gives you, no. What about negative 3? Doesn't a negative 3 multiplied by another negative 3 give you a positive 9? So it's impossible. You can't multiply digits with the same sign and get a negative answer. So sometimes we refer to this as undefined. You're going to be referring to it later as the letter I when you have to pull out the negatives. Okay, so nice little review here. I know this was your favorite topic back in the exponential chapter. Anyway, I'm just kidding. I know you didn't like it, but now it's your second exposure. It'll be easier. It's always easier the second time you see something. I ask you to find both the approximate and exact answer to each. So if you are giving me the approximate answer to the square root of 50, that means in your graphing calculator, you can go ahead and just type in the square root of 50. So if you don't have your graphing calculator, hit pause and go grab it. Welcome back. Alright, you hit second x squared to bring up that square root sign. So second x squared, type in the 50, and we get that, right? I just asked for approximate, so the square root of 50, it's not exact. It's about equal to, I would say, 7 and 7/100ths. We'll just go to hundredths place. So I'm going to use squiggly signs and say 7.07, because that's about. If I want an exact one, this is where we break this up, and we figure out what perfect square is located inside there that I could pull out. So this is where we say, okay, well, 50 has a perfect square factor of 25, so I can use 25 times 2. Yes, you're like, oh yeah, these, I know. Alright, the square root of 25 is 5, so that gets to come out. And 2 gets left in there because it's not a perfect square. So this is approximate, this is exact. Do the same thing with the next. I want the square root of 45. We'll give approximate, so hit second x squared, type in your 45, and it looks like it's about 6.7, and I would round that up to 1 because the number next to it is 5 or more. So about 6.71. To be exact, I'm going to see, does 45 have any perfect root factors? Yeah, 9. 9 times 5 is 45. 9 is a perfect square. So the square root of 9 is 3. It gets to come out. And 5 is left in there because it's not perfect. Nope. If you're not perfect, you can't come out. It's so sad. Because nobody's perfect. You know who I'm thinking of. Sing the song. Go ahead. Alright. Everyone makes mistakes. Here we go. Now I have this little negative sign out here. This means I want the opposite of, or I want the negative square root of. So take a look in here. Let's type in the square root of 90. Don't worry about the negative sign. Just bring it in there after. When you could, if you wanted, put in the little negative symbol there. And then second x squared, 90. Hit enter. and it'll tell you. And to the hundredths place, this would be negative 9.49. So it's about negative 9.49. If I want to be exact, okay, I'm going to have this negative sign out here. As I'm looking at 90, I'm seeing, okay, 9 times 10. And I know that 10 can get broken up some more just to make sure there aren't any perfect factors in there. I can put 5 times 2. So 9 times 5 times 2 would give you 90. 9 is the only perfect square in there. So 9 gets to come out. It comes out as 3, right? Square root of 9 is 3. So I have negative, because that's still there, 3. And 5 times 2 is 10. So this is approximate. This is actual. Good. All right. So let's apply this to quadratics now. Solving quadratics using square roots. Okay. So we learned that it's nice to factor quadratics and it's nice to graph quadratics when they're in standard form of ax squared plus bx plus c equals 0, right? Well, if you see a quadratic equation that's written in this form, where all you have is an x squared equaling something, the easiest way to solve it is by using square roots. Okay, so the method that I'm showing you today works best when the equation is written in that form, or can easily be written in that form. So notice there's not a bx, right? The bx term is missing when you want to solve it this way. Okay, so again, we have the two solutions, one real solution or no solutions, and you can tell either way. So I'll first show you this and then we'll just do a bunch of examples to get through. Let me zoom in here. Okay, so I have x squared equals d. When d is greater than 0, x squared has two real solutions, plus and minus d. This means the positive version of d and the negative version of d. When d is equal to 0, well, actually, I'll talk about that one in a minute. So let's talk about this one. Right now, I have 3x squared minus 27 equals 0, and I'm hoping you notice that the bx term is gone. It's not quite written in this form yet because I need this number to go on the other side. So step 1, we don't want standard form right now. I want the x squared term on one side and the constant on the other. So to make that happen, I'm going to add 27 because 27 was being subtracted. That gives me 0. So I'm left with 3x squared equals 27. Now at this point, I want to see, can I get rid of the number in front of the x squared term? Yes, I can. So let's divide this out. And we end up getting x squared equals 9. All right, now I have x squared equals d form, right? And you might be thinking, well, how do I solve this? Well, if I say x squared equals 9, all I'm asking you is, what number squared would give me 9? And to figure out what number squared would give me 9, all I need to do is take the square root of it. So the square root of x squared, because isn't the square root of x squared x? So taking the square root of a squared term gives me the base by itself, which is our goal. But remember, whatever you do to one side, you have to do to the other, right? Okay, so this is where I have 9, right? But when you have the square root of 9, the square root of 9 can be a positive 3 or a negative 3, can't it? So I'm going to put plus or minus in there. So that's what I mean. I want both versions, the positive and the negative version of whatever the root is. So x can be a positive or a negative, and the square root of 9 is 3. So this is actually two solutions because x can be a positive 3 or x can be a negative 3. You can write it like this, or you can write it like this. All of them are right. I want to put another one just so I can make like a short little stubby snowman, but I'll stop. Okay, so there's two solutions there. Maybe right now you're like, I have no idea what's going on. Don't worry. By the end of this, we'll be doing plenty of examples. You'll be fine. This is the first time you've ever seen this, so relax if you're freaking out. Okay, so when d equals 0, x squared equals d has one real solution. So right here, remember how our d term was greater than 0? That gave us two answers. Sometimes d is equal to 0, and that means we're going to have one real solution. X will be 0. So for starters, let's get all of the, well, not all of, let's get this negative 10 to the other side so I can have x squared equals d form. So I'm going to add 10 to make that happen. And I get x squared equals negative 10 plus 10 is 0. Okay, so now we have x squared equals d form, right? And I told you before that to get what number squared gives me x, all I have to do is take the square root of that term. And I'm supposed to take the square root of 0 as well. And remember before we put plus minus out here because I want the positive and negative version. Is there a positive and negative version of 0? No. So with this one, the square root of x squared is x because x times x is x squared. The square root of 0 is just 0. It's not a positive and a negative 0 because 0 is not positive or negative. So if your d is 0, that means your answer is going to be 0. So once you get in an x squared equals d form, if you see that d is 0, you're done. X is 0. All right. Now, of course, there's a chance for there to be no real solutions. When d is less than 0, that means there aren't any real solutions because you can't take the square root of a negative. And I'll show you what I mean. All right. So let's get this. Notice there's no bx, so I want to use this form. I want the x squared term by itself first, so I'm going to get rid of that 11. I'm left with negative 5x squared equals, and 16 minus 11, yep, that's 5. Now I want the x squared by itself, so I'm going to divide by negative 5, and I get x squared equals negative 1. Now at this point, you would take the square root of both sides, right? And when you take the square root of x squared, yes, you get x. But if I am taking the positive or negative version of the square root of negative 1, I'm going to be here for a really long time because that's not possible. What number squared would give me a negative 1? No, it's not 1 and it's not negative 1 because isn't a negative 1 times a negative 1 a positive 1? And a positive 1 times a positive 1 is a positive 1? So you can't, write down, can't take the square root of a negative and put an exclamation point or 2 to remind yourself and maybe make a mean face. I don't know. It's early in the morning. I just am babbling. I understand. Okay, so when you see you have to take the square root of a negative for your last step, that means there are no real solutions. Right? NRS, no real solutions. Okay, now example time. Turn your page. I know, it's crazy, but I want you to walk away from this understanding what you're doing. And most of these will go pretty quick. Okay, so we're searching for x squared equals d form, right? That's what we want all of these to be in before we can use this, and none of these have a bx, so it's good. All right, so for starters, this x squared isn't alone right now, right? That means that I want to get rid of this negative 3, so we're going to divide both sides by negative 3, and we get x squared equals, and negative 75 divided by negative 3 is 25, right? Okay, so x squared equals 25. To figure out what x is, I need to take the square root of it. That means I also need to take the square root of 25, but I want the positive and negative root. Yes? I hope? Okay. So square root of x squared is x because x times x is x. And I have a positive or negative. The square root of 25 is 5. And you're done with that one. There are two solutions. X can be a positive 5, x can be a negative 5. So again, you can write it that way, or you can say this. It's all good. All means the same thing. One down. All right, look at the next one. Again, there's not a bx term in here, so this is one that's appropriate for this method. I need this 12 to go away, though, so the x squared term is by itself. So I'm going to add a negative 12 or subtract 12, whatever floats your boat. And 10 minus 12, or 10 plus negative 12, gives you a negative 2. Now you're going to take the square root of each side, and remember positive or negative version of this. And can you take the square root of a negative? No, you can't take the square root of a negative, so this one has no real solutions. We're done with that one. See, that's not so bad. Maybe you're looking at the second row thinking, but these look like they're bad. None of them are bad. It all comes down to solving equations, and we love equations. Okay, I need this x squared term by itself first, so I'm going to get rid of that 15 that's being subtracted. So now I have my 4x squared, and negative 15 plus 15 is 0. Now I need to get rid of the 4, so the x squared can be by itself. And x squared equals 0. Do you remember what happens when x squared equals 0, when d is 0? We said that x just equals 0. because if you take the square root of 0, there's not a positive or negative version of it. There's just 0. Oh, I forgot to circle that answer. There. All right, next row. I told you they're going to go quick. Okay, this one looks a little bit different, doesn't it? It's supposed to be an x squared equals d form. Their parentheses wrapping this up, so it's this quantity squared. This is actually the form that I want. This is in x squared equals d form already. Okay, so here's what you do if I have a quantity squared. To figure out the value of, like, I'm going to write it, and then I think it'll make more sense. I want the square root of this, and then I want the positive or negative version of this. What we're trying to do right now is get rid of this squared, right? And to get rid of squared, all you have to do is take the square root. So what amount squared would give me x minus 1? X minus 1. Isn't x minus 1 times another x minus 1 squared? So that means the square root of x minus 1 squared is x minus 1. I'm going to say it one more time. The square root of a quantity of x minus 1 squared is x minus 1. Because isn't x minus 1 times the quantity of x minus 1 squared? So this amount squared gives me that. I know, we'll talk more in class if it's really confusing, but basically we're getting rid of the exponent, and you get rid of squaring something by taking the square root of it. So over here, I end up with a positive or a negative 5, right? Now this is where it gets a little bit different, because we're not quite done. My solutions aren't positive or negative 5. This is saying that x minus 1 can equal a positive 5, and x minus 1 can equal a negative 5. So we're actually going to have to break this party up into 2. Kind of reminds me a little bit of absolute value. Alright, so x minus 1 we said can equal the positive 5. Or x minus 1 can actually equal a negative 5 as well. And as you see, there are a couple more examples after this, so if you don't get after the first one, I'm sure after the next 2 you will. And even after that, I will help you out. You'll be fine. We just need to solve these 2 equations. These are 1 steps. So to get rid of subtracting 1, I'd add 1. So x can be 6. And again, add 1. X can be negative 4. So there's my 2 answers. And I knew I was going to get 2 answered because that d was greater than 0. Alright, let's try another one, just because that wasn't enough. Okay, so I have the quantity of x minus 3 squared equals 49. This is already x squared equals d form. To get rid of this squared, because that's my goal, that's my first step towards getting this x by itself, I'm going to take the square root of x minus 3 squared. Whatever you do to one side, you have to do to the other. And remember, the square root of 49 can be 7 or a negative 7, so I'm going to put this plus or minus in front of it. Okay, so the square root of x minus 3 squared is just x minus 3, and the square root of 49 is either a positive or a negative 7. So when you're stuck in this step, this is where you break it up, because x minus 3 can be a positive 7, or x minus 3 can be a negative 7. Positive 7, negative 7. You just solve both of these. They're just little 1 steps. So x can be 10, or x could be negative 4. What's really kind of nice, if you wanted to, you could type this equation in. You could bring over the 49, type this into your calculator, and then look at your graph and see, okay, does it touch the x-axis at 10 and negative 4? So yes, you'll have to show me your steps that you know how to do it this way, but you can use your graphing calculator to help you out, just to double check yourself. You're always asking, how can I check my work? That's how. Okay, so here, this isn't quite x squared equals d form, because I have a 4 out here. So step 1, before we take the square root of that, let's get rid of the 4. Oh, a fraction. It's okay, don't worry about it. So those are gone. Now I'm left with the quantity of x minus 3 squared equals 9/4. Just leave it like that. It's a lot easier than changing it to a decimal, because you know how we're going to be taking the square root of both sides? 9 and 4 are pretty friendly when it comes to taking the square root of things, aren't they? Alright, so now I've got the x squared equals d form. To get rid of the squared, I need to take the square root of both sides. And I want the positive and negative version of this. So the square root of the quantity of x minus 3 squared is, yes, x minus 3. And this is going to be a positive or negative. Remember, when you see this, it means the square root of the top and the square root of the bottom. So the equation I'm working with here is x minus 3 equals a positive or negative 3/2. And now I'll go ahead and I'll change this into 1.5 to make it easier to work with my equations. So x minus 3 either equals a positive 1.5 or x minus 3 can equal a negative 1.5. Either way, we just need to solve these out. So I'm going to add my 3. So x can be 4.5. I'm going to add my 3 again, and x can be 1.5. So yes, there are decimals too. They do exist. It's okay. It's very possible. All right, one last one. Of course, we have to have time for a story. So again, these are the math stories that stress my kids out before I tell them at bedtime, you know. I'm just kidding. They don't get stressed. They love them. Okay, a fish tank. Look at how cool. A fish tank has a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cubic feet. Find the length and width of the tank. Okay, there's some prior background knowledge you need to have. You need to know how to find the volume of a fish tank. What kind of shape is this? I know it looks a little distorted, but this is supposed to be a rectangular prism, right? A box. To find the volume of a box, because it tells you what the volume is. Do you remember the formula for that? Maybe this is the one everybody seems to remember. Volume of a rectangular prism or box is length times width times height, right? So we are going to be solving an equation here, because I give you some different parts to this that you know. So I tell you what the volume is, right? I tell you the volume is 270 cubic feet. So I'm going to plug in 270 for the volume. Okay, now I'm supposed to have the length times the width times the height. And only one's allowed to be missing, right? Isn't that how it works with an equation? So let's see. It says it has a height of 3 feet. So I'm going to replace the h with 3. And this is where it's a little bit trickier. It says its length is equal to 3 times its width. So if I'm looking for length and I'm looking for width, if the length is 3 times its width, I would say the length is 3 times whatever the width is, right? And width would just be width. So hopefully you're with me right here. If the width is w and the length is 3 times its width, the length would just be 3 times w. So for length, I'm going to plug in 3w, and for width, I'm just going to plug in w. And you might be thinking, well, what do I do now? Well, this is all multiplication, so multiply the ones that you can. So 270 equals, all right, I have 3w times w times 3. I know that 3 times 3 is 9. And what's w times w? Yep, it's w squared. So do we have a bx term on this? No, there's no bx. So I want to solve this using our lovely little square roots method. So that means I need this 9 to go away. I'm going to divide both sides by 9. The w's on the other side, it's okay. This is like an x. And 270 divided by 9. 9 goes into 27 3 times, bring over the 0. Okay, so now I'm going to have 2 answers here, right? Okay, so to figure out what w is, I need to get rid of this squared, right? That means I need to take the square root of w squared, and I also need to take the square root, positive or negative, of this 30. So the square root of w squared is w. All right, now for this one, let's just go with the, let's see, approximate. All right, so I want the square root of 30, so I'm going to type in second x squared 30, hit enter, and I get 5.47. So I'm going to call that 5.5. So 5.5. Now, I know that we wrote plus or minus here. Do you think the width could be negative? I hope not. No, you can't have a negative width, right? So I'm just going to keep the positive version of this. So the width right there is 5.5, and it's feet that we're dealing with. The question asks you to find the length and the width. So I know the width is 5.5. To find the length, didn't we say the length was equal to 3 times the width? Yep. So all I'm going to do is take 3 times 5.5. And when you take your 3 and you multiply it by your 5.5, yes, you get 16.5 feet. And it's about, I should use a squiggly because we round it. All right, that's enough of story time. I'll see you tomorrow.